So, hi all, welcome back to Malware Analysis. I am J. Lavanya, Assistant Professor of CSC Department. So, today in this video, we are going to discuss on the topic anti-malware analysis. Under this, we are going to discuss on SWF tools and FLASM. Okay, so let's dive into the topic. So, what is SWF tools? So it was historically a useful resource in anti-malware analysis for dissecting and inspecting some malicious Adobe Flash files. So analysts use it to perform static analysis on SWF, particularly before Adobe Flash Player was deprecated. So with the decline of Flash, the importance of SWF tools has diminished in modern malware analysis. But the techniques it enables remain relevant for other complex file formats. Okay, so this is about the SWF tools. And apart from that, we have seen so many cases where the SWF tools is used. Okay, so in case of Mac or Ubuntu, we will be using that. So it's a mainly actually a open source that it manipulates and converts the Adobe Flash files. It includes tools like PDF to SWS for converting PDF to SWF and SWF combined for merging some SWF files and SWF dump for extracting information from SWF files. Okay, so it is compatible with Linux, Windows, and Mac OS, and it is distributed under the GPL license. Okay, and what are the key features and tools? So PDF to SWF conversion. The PDF to SWF tool converts the PDF documents into SWF files, preserving text, tables, and graphics. And SWF file merging. The SWF combined tool that can insert SWF into a wrapper SWF that concatenates multiple SWF, or it stack them on top of each other. And SWF information extraction, so SWF dump that can be used to get some detailed information about the SWF files, including images, fonts, and sounds. Okay, and if you take like a text extraction, right? So this text extraction where we will use some SWF strings that can extract text data from SWF files. Okay, and next, like cross-platform compatibility. So SWF tools can be compiled from source to run on Linux, Microsoft Windows, and Apple OS X. So what are the use cases? Like web development, that is useful for developers who need to create or manipulate SWF content for some websites, games, or animations. And second thing, like educational tools. So creating interactive educational materials that can be easily distributed online. And like cultural preservation, like converting all the Flash animations into more current formats while preserving their original look and feel. The only limitation I could say is that command line interface. The command line interface can be a barrier for users who are not technically inclined. Okay, so this is a small intro of SWF tools. Now let us discuss on how SWF tools was used for malware analysis, right? So these are the things like SWF dump, as we have discussed, SWF extract, and SWF strings. Okay, So what is the main use of this, SWF dump, and why we are going for these kind of SWF tools is that, it's a command line suite of utilities for manipulating some SWF files in malware analysis. Its primary component is SWF dump followed by SWF extract. Okay. So what is SWF dump? So this tool printed out detailed information about an SWF file structure and content. So analysts would use it for the following, like code disassembly. That is, SWF dump could disassemble the action script bytecode embedded within an SWF. So this allowed analysts to read and understand the program's logic and identify some malicious functions, such as those that downloaded additional malware or exploited vulnerabilities. Okay, and like next is that structural analysis. So malware often relied on very specific and sometimes correct tag structures to trigger some exploits. So analysts could use some SWF dump to examine the sequence and arrangement of these tags to identify the anomalies. Okay, and next, like cross-reference data. So by analyzing the way internal elements refer to each other, analysts could map out the program's flow and identify the suspicious dependencies. Okay, and next, like SWF extract, this utility could extract some various components from an SWF file, including sounds, images, videos, and embedded action script code. So for a malware analyst, SWF extract was used to isolate and inspect some malicious component. Okay, and their like malicious SWF often hid their main payload inside an embedded element. So SWF extract could pull out these components for further analysis. And next, like unpacking the malicious files. So some flash malware was packed or obfuscated to hide its true purpose. So SWF extract was a critical first step in unpacking the SWF to get to the core or unobfuscated code or embedded files. And next, like SWF strings. So this tool scanned an SWF file for readable text string. So analysts, what they will do is that they will use it quickly to renovate or to hack through various clues to within the malicious code, such as URL or command and control server addresses, file names, or the error messages. Okay. And there are some declined relevance of SWF tools. The first, like Adobe Flash Player's end of life. So Adobe ended support for Flash Player in December 2020. So this prompted browser vendors and operating system to disable or remove the Flash entirely, rendering the malware threat vector largely obsolete. Okay, and shift to other file types. If we take, like, as Flash became a less viable attack vector, threat actors moved to other file formats and attack methods. So modern static analysis for malware focuses more on formats like PDF, Office documents like docx or XLSX, and executable, that is PE files. And next, like alternative tools. So while the SWFT tools was a primary command line option, other tools like the JPEX free flash decompiler offered a graphical interface for the SWF analysis. Okay, and next, like a command line tool suite that is called SWFRE tools was also developed specifically for reversing and analyzing the malicious SWF files. Okay, So this is all about the SWF tools. Okay. Now we are gonna see the next slide on FLASM. Okay. So what is FLASM? It is a legacy command line assembler and disassembler for AutoScript bytecode within the Shockwave Flash files, that is SWF files. So, for anti-malware analysis, it was historically used for static analysis and reversing some malicious SWF files to understand their functionality and extract the hidden payload. Okay, so why there are some cases where it is used. Okay, if you take like while largely absolute, due to the deprecation of Adobe Flash, FlashM was an important tool for malware analysis during the peak of Flash based exploits. Okay, and so and why FlashM was used in anti-malware analysis. The first of all is that it's a decompression and disassembly, and second like understanding malicious logic, third like modification and reassembly, and last one scripting and automation. So first of all, what is a decompression and disassembly? So FlashM could decompress SWF files and then disassemble the ActionScript bytecode into a human readable format. So this was the primary function for a malware analyst, as it allowed them to read the low-level code that would execute inside a victim's flash player. Okay, and next like understanding malicious logic. Okay, so by examining the disassembled bytecode, analysts could identify some malicious behaviors such as dropping the payload, identifying the code responsible for, you know, downloading or to, executing some malicious file from a command and control server. And next, like exploiting some vulnerabilities, locating the specific code, attempting to trigger a known vulnerability in the Flash player. And next, like obfuscation techniques, uncovering how the attackers attempted to hide their code by observing how the action script, was manipulated and decrypted at runtime. Okay. And next topic, like modification and reassembly. An analyst could use FlashM to make changes to the disassembled code and then reassemble back into a new SWF file. So this was useful for debugging, that is injecting the trace or logging function to get a clearer picture of the execution flow during the dynamic analysis. And second, like disarming the malware, removing the malicious code completely to create a benign version of the SWF for further research. And last, like scripting and automation, FlashM could be used in script to automate the analysis of large numbers of SWF files, extracting action script code and searching for a specific malicious pattern. Okay. And next, like, what are the limitations and modern context? Now let's discuss. So the first thing is primary limitation was its lack of support, for newer ActionScript version such as ActionScript 3.0, which is used by Flash 9 and later. So this meant it was ineffective against modern at the time. So Flash exploits. For analyzing the modern threat, Flash is no longer relevant due to the end of life of Adobe Flash Player. So for historical malware analysis or some specific tasks which requiring a command line tool, some alternatives or superior tools include like RABCDA SM, and JPX is free flash decompiler, and third like static and dynamic analysis sandbox. So this RABCDA is a successor to FLASM that supports ActionScript 3.0 and is considered a more powerful and modern alternative for some ActionScript bytecode manipulation. Okay, and here if you take this JPX free flash decompiler, a popular graphical tool that can decompile and analyze the SWF files more effectively than command line tools like FlashM. And last, like static and dynamic analysis sandboxes, modern malware analysis environments such as FLAR VM from Madian contain some pre-configured tools for automated analysis and dynamic observation of malware behavior, just more reliable some static inspection of some action script bytecode. Okay, and apart from that, and if you take on this here, the common uses for flash tools include some fixing some brick phones when a software update fails and the phone no longer turns on, a flash tool can restore it. And second common use like upgrading or downgrading the OS, you can install a newer or older version of the OS. And third, like installing custom ROM, advanced users can install a customized version of Android for better performance or to get rid of some pre-installed bloatware. And next, like fixing some software issues, you can resolve some common software problems like boot loops, glitches, or a device that has slowed down over time. And next, like unlocking or relocking the bootloader. So this process is necessary to gain the root access or to install some custom software. Okay, the flash tools like it is used by the manufacturer, like in Google Pix phone. Android flash tool was used officially. It is a base tool, right? Like AOSP based on the pixel size they will be developing and they will use. And for MediaTek devices too, they will use a term called SP flash tool, that is smartphone flash tool, where the MediaTek chipsets will use an Odin flash tool and QFull tool, that is a Qualcomm flash image loader. And for Xiaomi or Redmi 4 Mi Flash Pro, it is used as a chipset. And for a multi-brand flash tool like Miracle Box or Ultimate Multi Tool, some kind of flash tools they are commonly using. Okay, so in this session, we have discussed in detail about the what are the various flashing tools and what are the limitations and what are the main common uses of it, right? And apart from that, we have discussed on SWFT tools. Okay, so this SWFT tools, what is meant by it, and what are the how it is used in malware analysis. Okay, and how we can able to decline relevance of SWFT tools. Okay, so all those cases we have discussed. I hope this video will be very useful to you. So thank you all.